has like phi being this angle off of the z-axis, I think, unless I'm misremembering this. And what I'm currently trying to do is a combination of location and, okay, it's theta. Combination of location and that place it's looking. And spherical coordinates can't encode like a rotation. I'd have to use Euler angles. But I don't want to use Euler angles. I'll probably end up using quaternions. But I did figure out why this is a blank screen. This is a blank screen because I'm rotating it in place, so it's just looking like here. So I need to rotate it, then translate it to this place. Oh, this actually would be useful for polar coordinates. Because if this is pi over 4, and I have the wrong variable here, if this is pi over 4, and I already rotated this by pi over 4, then the polar coordinates are like 11 pi over 4. I'll get a tablet one day, guys, I promise. And theta is off the x-axis? Oh wait, so then it's like pi over 2? I think theta would be pi over 2. But if I get this wrong, it's not going to appear. Anyway, then I can just convert this to x. I can just convert this to Cartesian like this, I guess. But I have to get all these angles right. Hold on. Here, the angle off the x-axis in the right-handed direction is 3/4 tau. It's going all the way around here. So that's... Oh no, I was right. This is phi. This is phi. Oh my gosh. This is theta. This is phi. Okay, so what I'm going to do now is just compute the Cartesian coordinates that are from 11... Oh my gosh. Theta is 3/4 tau. And this is pi over 4. And then try to move it there. And I don't think it'll work, but that's what I'm going to try to do. So this... Rotate the camera in place. Pi over 4. Which I think I'm just going to use tau for everything now. So pi over 4. It's going to be tau over 8. Tau over 8. How do I describe this direction? Up the y-axis? Along. And the way I can see that is if I move this in time. If I wait for 1 second, and the amount that I rotate this on each time step is dt divided by tau over 8. Then, when it reaches 1 second, it should be looking in the same place that this is looking after I do this rotation. So I'm not going to do this. Oh, whoops. Not going to do this. And this will show me where the camera's looking in slow motion. Wait, no updater. Oh, I want to just stop after that. Oh, this is what's happening to the camera. Oh, I want to just stop after that. Oh, this is what's happening to the camera. Wait, no, this doesn't make sense. Oh, it's because I'm... Wait, here I'm rotating it in place. When I do this, I'm not rotating it in place, right? Because I'm not doing the translation to the origin and stuff. So how come this can't see it? We're getting into some deep math here. Hold your horses. This, I'm gonna comment, rotate the camera place. That's not what I'm doing. I'm gonna rotate this by dt divided by this. Now, when this reaches 1 second, we'll have completed this rotation by tau over 8. I think. And I don't see anything. And why is that? Okay, why did nothing happen? Oh, I added the updater within the updater, so that doesn't make sense. That time I didn't see anything either, though. Okay, work with me here. Alright, the square has disappeared. I repeat, the square has officially... Oh, that makes sense. Now the square will appear. And now I'm going to slowly rotate the camera. And it is rotating in place, it looks like. But why is that happening if I don't translate it? I might be really bad at math here. So one thing, this should be dt times tau over 8. Because then when this reaches 1, the cumulative rotation will have reached tau over 8. So this is what's happening. And it looks like the camera actually is moving. The square's getting flatter in the x direction, which means it must be rotating along the x-axis. Wait, but it's not rotating around the x-axis. If it was rotating around the x-axis, I would expect the square to get thinner in the y direction. But it's not doing that. Something's up. I suggest you print the current position and Euler angles of the camera to the screen to track what is actually happening. I actually figured it out. I'm right multiplying instead of left multiplying. Well, I don't know if that was actually the problem, but that is something that was wrong. But I think you're right, too. I should probably print the position and Euler angles of the camera. Let me try this, though. Okay, it still actually doesn't make sense. Okay, so I'm going to print self.camera.get, was it like get position or something? Get position. Oh my gosh, give me a break. Wait, why is that not printing at all? Oh, I didn't add the updater. Wait! The square is rotating. That's why. Why didn't anyone tell me? I'm kidding. I didn't know either. But yeah, the square was rotating the whole time. So now when I rotate around the x-axis, nothing's happening. I didn't know either. But yeah, the square was rotating the whole time. So now when I rotate around the x-axis, nothing's happening. Which also doesn't make sense, actually. Oh, because I didn't add the updater. Then I add the updater. And now I rotate it. And now I see it shrinking in the y direction. I didn't want to spoil it. So now I see it shrinking in the y direction, which makes sense because it's rotating around the x-axis. It's moving along this line, which is exactly what I want. Wait. Oh, I didn't know you could erase like that. It's moving along this line. And so the square, which is here, is like getting thinner. Okay. We did it. So this, if I pause it like this will have the square. Oh my gosh, give me a break. This will have the square like, oh, why isn't it there? What did I do? Oh, I'm right multiplying again. This is why I need functions for this. Getting all of this math right. Okay, perfect. Now, I've successfully moved that camera here. Now I want to rotate it around the z-axis. And when I rotate it, I want it to still be looking at the square, I guess. Okay. So what I'm going to try doing... Okay, this isn't in place. This is rotating the camera. Tower 8 around the x-axis. That's what it's doing. Now I'm going to try to rotate the camera around the z-axis. And the way to do that is to multiply its model matrix by a rotation matrix on the left by just like sum. And not the right. I'll print the positions too. X, Y, the Z coordinate is remaining constant. The Y coordinate is decreasing. So if it's here, and it's rotating around the Z axis, and I'm using the right hand rule here, then it's going to be rotating in this path. So its Y coordinate should be decreasing, its X coordinate should be increasing, and it is increasing. Y is increasing? You're right, Y is increasing. Which is bad. Y is -7. No, wait, this is good. Y is -7. It's increasing as it rotates this way, and X is increasing, and I would expect it to eventually decrease. So if I do this for a long time, what I think, what I'm seeing here is the same motion as when I do this. But there's a square on the ground, so I see this. So that's not as hard as I thought it was, actually. Okay. So the next thing I want to see... rotate the camera around the z-axis. I also want to make sure I can do the other motion. Now I'm actually not sure if I'll have to use quaternions. So I can do this motion, I think. The only other thing I'll need... Oh, wait! I'll deal with that later. I can do this motion. Then I want to be able to do this motion. But I think this... Well, this isn't multiplying... This isn't rotating around the x-axis motion. But I think this... Well, this isn't multiplying... This isn't rotating around the x-axis. Because the x-axis is rotating in this plane. So what is this rotating around? Maybe I will need a quaternion. Another thing is... when I shift the camera... I guess that doesn't change rotation around the z... No, that will change rotation around the z-axis. I'm actually not sure of the math when I shift the camera. But I can do rotation around the x-axis, I think, fairly easily. I'll just need, like, total time. No, wait, maybe it's not fairly easy. It's an angle off the normal vector. Wait, what is? You'll have to be more specific. So here's what I want to do. I want to rotate around... Oh, wait, yeah, I don't even know what to rotate around since this is moving. Dang, okay, more math. This is kind of a useful picture, actually. Let me duplicate this. So now, this is the situation. The shifting is an angle off the normal vector. I'm still not totally sure what you mean. But I think you're right. I think the thing that you're trying to communicate is right. But here's the problem I'm running into at this point. The z-axis looks like this. The camera is going to be somewhere looking at the origin, which eventually it won't be looking at the origin, but I can get to that later, I guess. Now I want to rotate the camera further down the z-axis and to rotate it in this direction. The question, or the normal vector orient you. I think I'm about to do the same thing, or compute the same normal vector you're talking about. And the reason I think that is that in order to find an axis where I can rotate this, an axis around which I can rotate the camera in order for it to come down, I guess, I'll have to get something normal to the z-axis and normal to the vector from the camera to the origin. So if I cross the z-axis and this vector, I'll get a vector. Right-hand rule. If I cross the camera vector and z, then I'll get something out of the screen. And if I rotate around that, then I'll rotate in the other direction, actually. So let me not do that. Well, I guess it depends on which direction I want. But in order to rotate downwards, Then I'll take Z cross with C. Am I doing this right? Yeah, that's into the screen. I rotate around this, it'll bring me down. Normal to the plane, I mean. Yeah, that's true. Yep, that's true, because I have this Z-axis. Is that all I need? So then there's a question. This vector, Z cross C, there's no way this is a well-behaved vector. This is going to be the most random vector in the world. This vector, Z cross C, there's no way this is a well-behaved vector. This is going to be the most random vector in the world. Although I think there are already utility functions for computing the rotation matrix around an arbitrary vector. But here's what I'm going to do. I'm going to compute the vector to the camera. I'll say, and this is going to be camera, this minus the origin, so just this. And then the Z-axis is just Z. So where am I measuring this angle? I guess I think I should be measuring the angle like this, which makes sense. So to increase the angle off the Z-axis, I'll have to cross those. So axis of rotation equals, is this a real function? I don't know if it is. I guess so. Then I want to rotate around this axis. Okay. And how does one rotate around this axis? I think there's something in this in space ops. Rotation r cubed around a specified axis of rotation. That's convenient. It's too bad that... Wait. Rotation about Z. Well, this is one problem. This is a 3x3 matrix. And this is using homogeneous coordinates. So I'll probably have to convert this to homogeneous. But... it's not clear to me. Oh, I guess this is how you can matrix multiply a bunch of things. Is this in 3 dimensions? I guess it has to be, since it's adding the extra dimension here. Rotation matrix transpose. Okay, I think I just have to use this. I wonder which of these used a quaternion. Rotation about Z doesn't. Is it Z to vector? Rotation about Z just uses this matrix. I actually don't know where he ended up using quaternions. Rotate vector. Okay, that's not what I'm trying to do. Rotation matrix transpose. This uses a quaternion. I wonder why the rotation matrix transpose does, but the regular rotation matrix doesn't. In any case, if I don't have to use a quaternion, it's probably better for me. That said, I'm not super confident that this will work. So I just call this rotation matrix. And I say like space ops. The angle, let's do dt and axis. Axis of rotation. Okay, maybe then I can just left multiply this by this, and maybe that'll rotate around that. Left multiply this by this, and maybe that'll rotate around that axis. So I'm going to pause the rotation around the z-axis. This is like increase the angle off the z-axis. Okay, let's see if that works. And I didn't end up using the time yet, that's fine. I have to import space ops. Okay. It's still not defined. Is this not how you do this? I should probably learn Python one day. Problem with Mapple. Input operand 1 has a mismatch in its core dimension 0 with whatever. What? What did it return? Rotation matrix. This is space ops rotation matrix. What does this return? Oh, this is a 3x3 matrix. Okay, so I have to convert this to homogeneous coordinates. Which is going to involve horizontal stack. So on the right side of it, I have to put 0, 0, 0. So would this be like 0, 0, 0. So now if I print it, you should see the 0, 0, 0 on the right side. Just kidding, I see it has no attribute h stack. In p.h stack, let's try that. Takes one positional argument to what we're given. Yeah, this takes a tuple. Okay, so I'm printing two things. Then I'm printing the camera's position, which I don't actually need to print right now. I'll comment that. So now I added the 0, 0, 0 there. Then at the bottom, I need 0, 0, 0, 1. So I'll v-stack this with 0, 0, 0, 1. So this should be a 4x4. I did something. Wait, hold on. Stop printing this. This is only by DT. It's rotating all the way down and then stopping. Which I guess makes sense. First of all, this is way too fast. Can I get it divided by 8 in here? Okay, so this is doing what it's supposed to do. Right now it's rotating all the way down here and then stopping. Which I guess is what this is doing too. I don't know why there's that maximum angle. I don't know why that even happens. But I guess... No, I don't know why that happens.